The next topic at hand is logical operators. Logical operators are needed for when you need more than one condition to satisfy for an if statement or an else if statement. So if you have if x is greater than, if you want to check x is greater than 0, that's one condition. That's fine. But if you want to make sure, for example, for age, so let's say if we have int age, and this could be initialized to some value, or a user could enter this in. If we have age and we want to see, we want to put restrictions on age. So you want to make sure that an age is valid. So you want to say the age, you want it to be greater than 0 because a person's age can't be negative, but you also want to set a limit. So you want to set, let's say 100 or 105 for a person's age. So therefore the condition is no longer simple. You would basically have two conditions. So you want to have if age is greater or equal to 0, and you also want age to be, maybe less than or equal to 99. And then here you would say, for example, println age is valid else println not valid. Something like that, right? But what goes here is key. So you basically want to say so you basically are giving an interval, right? You're basically saying this and this. So you want both those conditions to be true. So in these situations, you would put and. The symbol to go here is actually, so this is call and. And we'll go through this in detail. So you see, you basically want an interval, right? You want an interval where it starts with 0 and it ends at 99. This is the interval that you're interested in. Any numbers that fall outside of this interval, you basically don't want. It's not gonna be valid. So for example, if a person's age was entered as 55, then of course it's valid. If it was entered at 155, then it wouldn't be valid because it wouldn't fall on their it wouldn't be true, right? So this here, it's getting a little busy, but this here is, again, a logical expression. So you see, as we move forward into this, the logical expressions are becoming more complicated. Logical operators that we're going to visit in this course include and, or, and not. Not we've already sort of seen in combined with the equal sign. So recall the not operator. Of course, it's used there, but this together, or it's actually an operator. But you remember that. So when you have conditions, let's look at the truth table first of all. We'll go through these examples. This is called the truth table. When you have two conditions, the first one is true and the other one is true, the result is true. If one of them is true, the other one is false, the result is always going to be false. So that's the difference between an and an or. Whereas or, the only way you could get a false is that if both of them were false. This is pretty much we're getting into logic here, right? So I'll tell you what I mean. So if I said I will go out today if it's sunny and if I have a class. So then I would go out if both those conditions are satisfied. So if it's so I will go if it is sunny and I have class. So if either of these conditions are not true, I'm not going to go out. So I go out. So actually, the way we write it in programming is if it's sunny and I have class, then I go out. So if it's not sunny, I won't go out, even though I have class. So I'm assuming I'm pretty lazy. If I have class, if I don't have class but it's sunny, again, I don't go out, right? But or is different. So if I had or, I could say if sunny or I have class, I go out. In this case, they either or. So if it's sunny, I go out. If I have class, doesn't matter if it's sunny or not, I go out. So like this is an or. If I have class and it's sunny, then great, I still go out. So in this case, this logical expression is true if both conditions, we have two conditions, right? So one condition and two condition. So if both conditions, well, actually, sorry, in this case is true if at least one of the conditions is true. So if at least one of them is true, this is true. But in this case, this is true if both conditions are true. So if both conditions are true, then this is true. But here, if one of them is true, then we're fine. So, looking at some examples here, going back in the slides. So we'll talk about the not in a minute. So here, if you have an age, we say if age is greater than or equal to 0 and age is less than 90, it's valid. So again, we're looking at an interval 0, 99. Here, it's sort of a random question. If x equals 7, y 9, so you have x as 7, y as 9, you have a as 2, and b as 3. So we say if x is less than y. Let's see if this is true. Is x less than y? Let's find out. X is less than y, so this is true. But this also must be true for us to enter this if block. Is b greater than a? B is greater than a. So the output, we actually output this. So this logical expression is true. Let's look at another example for the or. So or is different. Or is, so in here, if the temperature is more than 25 or less than 0, you print out the temperature is not desirable. So here we are looking at an interval. So if this is 0, this is 25. Now we're looking at this interval or this interval, right? So with and, you're usually looking at sort of the middle piece. With or, you're looking at either side. So if temperature is less than 0, or if it's greater than 25, it's not desirable. You could have an else here. and basically say temperature is desirable. So anything else, so as long as it's not less than 0, as long as it's not greater than 25, in here, this is going to be R, this is going to be R else. Make sense? Let's do a question on this with regards to chars. Let's say we have char ch, and we can get this from the user. I'm just going to initialize it to be so that it's simple. We can say if we want to check to make sure, that ch is part of the alphabet, right? So we want to make sure it's part of the alphabet. So we would say if ch is greater than or equal to lowercase a, and ch is less than or equal to lowercase z, or sorry, single quotations. So if you have this, we are checking to make sure that a falls between lowercase a. So sorry, ch is falling between lowercase a all the way to lowercase z. If you recall the ASCII table, basically uppercase a is here, uppercase z is here, then in between them we have 32 other characters, and then we have this. So if we want to make sure that our character is a letter, we would actually say it would belong to, so we would say we want ch to belong to this range, and we want it to belong to this range. We don't want this range, we don't want this range, we also don't want this range. So this here is covering this range. Put another bracket here. And I'm going to write the so if we want it to be to this range, or I'm going to continue writing down here, ch greater or equal to uppercase a, and ch less than or equal to uppercase z. So we have this whole thing is a logical expression, right? This whole thing is a logical expression. So if this is the case, maybe we print ln ch is a letter. So if, for example, ch which was written was let's say uppercase b, this top logical expression ch is greater than lowercase a and ch is less than z, so it's not going to fall here. So this little bit, this here is actually going to be false. And then down here, so b is gonna fall in this range. So this logical expression is gonna be true. So now we have false or true. That means this is, as a whole, is actually true. So this would be outputted to the screen. Alternatively, if I entered, let's say, what did I have? So when I say B, this should have quotations. I apologize if I didn't have quotations on that before. If I enter another character, so let's say if I enter the number sign, which is part of it, the number sign, this one, this is going to be false, the bottom one now also is going to be false. So false or false, we're going to get false. So this is not going to be outputted. So CH is a letter, is not going to be outputted. So hopefully that's clear. In the lab, we're going to do questions on this, so hopefully you guys will be very clear on this concept. The not is actually fairly easy. It's different from the other two. The other two are binary operators. That means they need two operands, right? They need two operands because they're binary. This is unary. Basically, if A is false, when you say not A, that means not false. So the output here, the output is actually today is a nice day. That's the output because A is false. This is saying not false. So if not false, which is true, so not false is actually true. That's why we would go in here. Here, A is 50. So if A is greater than 20, this is actually true. Then we have the not here. So you're saying not true, which as a whole ends up being false. So then there is nothing prints. So try this in PDE, in processing, and get some practice with it. But basically, not is when you say not true, it becomes false. When you say not false, it becomes true. So it's a logical thing. It's not used as often as and and or. And and or are quite useful. This one you don't see as much of it, but it's important to know what it's about. So let's answer a question, and we'll be back with a little bit more material. The last topic we're going to look at in our decision structures lecture series is the topic of nested if and else statements. Basically what that means is when you have a decision inside another decision. So consider the following. So if you have we solved this before. So if you have x is less than 7 and b is greater than a, you can actually write this way. You can actually write it as a nested if statement. So you can have an if inside another if. So if x is less than y, then you're going to go here and you're going to have if b is less than a. So the AND operator actually can always you can have a logical expression using an AND operator or be a nested loop, nested if statements. One thing you have to realize that in an if statement, the most left condition is always read first. So that's quite important. So this one is first evaluated and then this one is evaluated, right? So so here you can have the first one as the outer statement. So this is the outer statement, where this here is the inner statement. This becomes useful when you have a lot of decision to make inside another branch. So this is how branching basically works.